Here we have a rectangle PQRS. Inscribed inside the rectangle is a semicircle with its center at the point O and radius R units. Also inscribed inside this rectangle is a small circle with its center at the point A and radius say R units. Now what we need to find is the ratio of the areas of this circle and this semicircle. Now when two circles touch externally, what do we know? Both of their centers and the point of contact. All these 3 points are collinear, or in other words, they lie on the same line. Not only that, the distance between the centers is given as the sum of their radii. Now we have the same situation here. You can see that these two circles are touching externally at this point here, which means the distance between their centers is the sum of their radii, or in other words, OA is given by this much is also going to be R. OA is given by R plus R. What we are going to do is find another expression for OA and equate the two. Now, you see this point where the semicircle touches the rectangle. Let me name it T. Then, what sort of a quadrilateral will this POTS be? You will see that it is a square of sides R units. Can you tell me why that is? What we started with, our PQRS was a rectangle, which means what? All the 4 angles of a rectangle are 90 degrees. So angle P is 90 and S is 90. And what else do you notice? Here you have a radius, and this is a tangent because it touches exactly in one point. And what do we know? The place where the radius and the tangent meet, they make a 90 degrees. Now if you look at this quadrilateral POTS, you have 390 degrees here. So the sum of the angles of a quadrilateral is 360. 360 minus 270, which gives you a right angle. The fourth angle is also a right angle. So what you have is a rectangle. All the 4 angles are 90. You have a rectangle, which means opposite sides are equal. Here an R means here an R. Also OT is also a radius. So that is also R, which means this is also an R. We have a beautiful rectangle whose all 4 sides are equal, which means what? It is a square. It is a square with side length R units. Now you see this point where the circle and the rectangle touch. From that point, drop a perpendicular to the side OT. Then how much will AM be? Now let this point be B. Then BM is going to be R. Can you tell me why that is? POTS is a square. What do we know about the opposite sides of a square? Not only are they equal, they are parallel as well. And what do we know about parallel sides? Their height, the distance between them is always constant. So, whichever side, whichever line connects PS and OT, it will all be of the same length. If this is R and this is R, then this will also be R. But then from that you remove this. How much is this? The radius, it is going to be R, right? So if you remove this, how much is AM going to be? It is going to be R minus R. Now again, from the place where the circle and the rectangle meet each other, let me name it C. From that point, drop a perpendicular to this side. Then what will CN be? The whole of CN is going to be R units. It is the same story. From that CN, remove this much. Remove this R. Then how much is AN going to be? AN going to be R minus R. Then what sort of a figure is ONAM going to be? It is going to be a square of side length r minus r. Why is that? If you look at this quadrilateral ONAM, we already found that here we had a 90 degrees and these two were perpendicular lines. We had drawn perpendicular lines. So that means again you have two 90 degrees. That means what? The fourth angle is also 90 degrees because the sum of angles of a quadrilateral is 360 degrees. So what you have here is a rectangle. But then what do you see? This side is r minus r. Rectangle means opposite sides are equal. Again, these two sides are going to be equal. So what we have here is a square with side length r minus r. But then when you have a square of length, say a units, then what about its diagonal? Its diagonal will be of measure square root of 2 into a. So any diagonal of this square is going to be square root of 2 into r minus r. But then what is OA? OA is a diagonal, which means what? OA is going to be square root of 2 into r minus r. So there we have got another expression for OA. All we have to do is equate these two and get a ratio between the two squares. What we have here is the ratio of the radii. What we need is the ratio of the areas. What is the area of the semicircle? It is a semicircle. So it is pi r square by 2. And what is the area of the circle? It is going to be pi r square, which means r by r the whole square into 1 by 2. Now, before squaring it, I will first rationalize the denominator. To rationalize the denominator, I will multiply both the denominator and the numerator by the conjugate of root 2 minus 1, which is what? Root 2 plus 1. So you have 1 plus root 2, the whole square, by 2, which is root 2 plus 1, the whole raised to 4, by 2. This is the answer that we were looking for. The ratio of the areas of the semicircle and the circle is given by this formula. That is all for today. You take care. Assalamu alaikum.